So let's start with what is called a linear search. In fact, the idea is very simple. It's an exhaustive search at every possible location. So remember, we are talking of a list. We start at the very beginning and we basically compare every item of the list to what we are looking for. So for example, let's say I'm searching for 2 in this list. I compare the 0th item, which is 11. That's not 2. So I move to the next item. Well, indeed is 2. I say, okay, look, the item was found here. I terminate my algorithm and that's it, right? So I return, for example, 2. Remember, the problem is to find that element. If you do find it, tell me where it is, and in this case it's found at 1. So I terminate and I tell, look, it's found at 1. On the other hand, say for example I'm searching for 28. Well, no problem, I can just exhaustively continue. So I just go and say, okay, this, then this, then this. I keep on going till the end in steps of 1, which is basically, like I said, exhaustively searching. I find that, look, there was no 28 in this, so I just tell, maybe I return a -1 or some kind of special value, or sometimes even perhaps raise an exception. For example, what happens in the index function in Python. We'll talk about that a little bit later. But basically, if I were to express this in words, you know, search the item of interest in the list sequentially, terminate the search in one of the two conditions, which is that item of interest is not found, or the entire list has been searched and let's say the item is not found, right? So this is basically it. This is linear search. We can write some code for it. So here I get to my my collab screen. I just, let's say, give a title here, say linear search, and I'm going to create a code, let's say code cell. I just define a function called, let's say, linear search. So linear search on a list for a target value x, right? So let's just put a small comment here. So linear search in a list on a list L for value x. So value we are looking for, let's say x inside this list, right? So basically finding x in L using linear search. Like I said, the idea is to sequentially search every item exhaustively. I can do this with a for loop. So I just go and say for kk in range, say len of L. Start from 0, go all the way until length of L -1. That's what this for statement will do. If I find that the item is indeed equal to x, so if lkk is equal to x, it means item has been found. I can just go and return kk. That is the index where the item is. On the other hand, if I, let's say, run through all values of kk, I do not find the item, I can just return a -1. Now this is exactly what we were kind of depicting diagram. Remember, return statement makes the function, let's say get over and return this value, which means that even though I don't explicitly have a break over here, the return statement is going to do the same exact thing, right? Also see that, also notice that, look, if I were to come to this line, it only happens in a situation where this condition never comes true, which means I kind of exhaustively search to the list, I don't find the item, in which case obviously I have to return, for example, -1. So because -1 is the value that I return when the item is not found. Now this is linear search, simple, not very hard at all. First time when I run it, it takes a while, as always, but we will just test this out so that we are sure that this is working, right? So I just take another code cell over here. I can just go and say linear search, for example, linear, say, search. Maybe I'll give a list L as, let's say, 10, 11, say 12, 1, 3, 4, 8, maybe 1, 4, 5, say 23, because remember, list has no particular order or something like that. If I were to search for, let's say, 5 in this list, oops, my bad here. So if I were to search for 5 in this list, I can just click this button. You notice I get answer of 6 because look, 5 is found here. This is 0, 1, 2, 3, 4, 5, 6. So 5 is found at, let's say, location 6, item, let's say index number 6. That's why I get a 6 over here. Let's say I were to try looking for 50 on the other hand. We know that 50 is not a part of this list. I expect the answer to be -1, and indeed it comes out as -1, right? So very, let's say, simple to understand, very first cut, I would say. But this is what linear search is. In the next video, we'll study the efficiency and correctness of linear search, a little bit more thoroughly. But I hope you found this interesting. In the Byte Olympia track, we are looking at algorithms very carefully. Do look at our website www.ybyte.in to find more such content and enjoy programming. Take care. Thank you so much. Bye bye.